Alright, so yesterday we did an introduction to elimination, and today we're going to continue looking at this process, but with the scenario where we might have to do some multiplication as well. So in order for a variable to be eliminated, you must have opposite terms. So that means plus and minus terms that are the same number. That would add to 0. If you are not given opposites, then you must create them using multiplication. So if we take a look at example 1, our x's are clearly not canceling out right now. They would combine to 7x. And our y's currently would combine to 6x, but they're so close to being opposites, to being what I'm looking for. What would be ideal is if somehow one of them became a negative 3y. And so that's exactly what we're going to do. I want that to be a negative 3y, which means out front, I'm going to multiply by whatever I need to make that happen. So currently, since it's positive 3y, if I multiply it by a negative 1, that will give me that negative 3y I want so that it cancels out with positive 3y. Now, could I instead have done this on the bottom row? Absolutely. We could put the negative 1 on the bottom and also make this a negative 3y, and it would still work that way as well. Okay? But for right now, we're going to go ahead and put it on the top. So when I make this a negative 3y, I also have to change everything else in the equation or it messes up our true statement. Okay, so we're kind of thinking of the distributive property here. So negative 1 times 2x is negative 2x. Negative 1 times 3y is negative 3y, which is what I was looking for. That's why I picked negative 1. And then even the very last number, negative 1 times 4 is negative 4. Now the bottom row doesn't change at all because I want that plus 3y right here to cancel out with the minus 3y. So I didn't have to alter or change anything about the second equation. And now we're just going to add like we did yesterday. So I know my y should cancel. That's why I picked the negative 1 to multiply by. And now I'm adding negative 2x plus 5x, which will really give me positive 3x when I combine them. And a negative 4 minus 8 gets more negative to negative 12. So then to solve for x, we simply divide by 3, and we get negative 4. Okay, and this part is the same as yesterday. We then go back, and I always go back to one of the original equations. Can we plug it into this new one we made? Absolutely. But usually we're multiplying it by a number that gives us bigger numbers or negative numbers, and we'd like to avoid those if possible. So I'm actually just going to go back to one of the original two. So let's say we pick the top one. So we're picking 2x plus 3y equals 4. And what I'm plugging in is, instead of x, I'm plugging in a negative 4 for x. So that becomes 2 times negative 4 plus 3y equals 4. 2 times negative 4 becomes negative 8. And then we're solving a two-step equation, so you have to think of your opposites, or how to undo what's being done to y in this case. So we have to undo addition and subtraction first. So if we have a minus 8 or a negative 8, we'll have to add 8 to both sides, which will leave me with 3y equals 12. And so then we divide by, divide by 3, and we get that y equals 4. All right, and so for our final answer, we're going to put negative 4 as x and positive 4 as y. It's always x comma y for our answer. So really the only new part of this problem was the very beginning. We didn't have opposites ready to go, so we had to create our own. And that's really going to be the hard part for most of you, is you're going to go, how do I know what to multiply by? Well, the truth is there's lots of ways to do these. So you're just going to try to see the easiest way to create opposites. So if your numbers are already the same, we just need a negative sign for one of them, which means multiplying by negative 1. Let's take a look at another example. Alright, so in this one, there aren't any that are already close to being opposites. In fact, they looked very different. I have a 3x and a 4x, and to create opposites, I would somehow have to change both of them because 3 can't become a 4 and 4 can't become a 3. So then when I look at y's, I'm thinking, how can I somehow make these opposites that will cancel out? I have a plus 2y on top and then a minus y on the bottom. What would be great is if this could become a minus 2y. That would give me the opposite I'm looking for. So the minus is already there this time. We don't need a new negative. We just need a 2. So we're going to multiply by 2 on the outside. And just like last time, we have to make sure to distribute all the way through. Okay? So our first equation is going to be exactly the same. 3x plus 2y equals 10. And our bottom equation is where we're going to multiply by 2. So 4x becomes 8x. Minus y becomes minus 2y. And 6, don't forget the 6, becomes 12. Okay? And now we're going to combine. Now hopefully our y's cancel out, because that's why we picked this 2 over here in the first place, was to get those to be opposites. So it looks like that is the case. A plus 2y and a minus 2y would cancel out. 3x plus 8x becomes 11x. And 10 plus 12 is 22. So it looks like we're going to get an x value of 2. So then we're going to go back to one of our original equations. I'm just going to pick the top one again, no particular reason. So that says 3x plus 2y equals 10. And then for x, I'm going to plug in a positive 2. And so that's going to become 6 plus 2y equals 10. So undo addition and subtraction first. So we have to undo a plus 6 by subtracting 6. And then 10 minus 6 becomes 4. Divide by that 2 and we get y equals 2. So for this one, our final answer, our x was 2 and oh, they're the same. So that one's kind of hard to mess up. So 2, 2 is our final answer. All right, let's try one more of these. All right, so on this one, again, I don't see anything obviously jumping out as opposites. But look, 2 can't become negative 3 and 3 can't become negative 2. Like, I would have to change both of those numbers to somehow create things that would cancel out. However, I can get a 2 to look like a 6, right? And they're already opposite signs. So if I could somehow get this 2 to look like a 6, that way they would cancel out. I'd be good to go. So then you have to ask yourself, well, what do I need to multiply a 2 by to become 6? And we're going to get a 3. So in this case, we're going to change that second equation again. The top equation is going to stay the same. I'm going to have to kind of like come down here a little bit for space reasons. So the top equation stays 2x plus 6y equals 7. The bottom equation gets multiplied by 3. So 3 times 3 is 9x. 3 times minus 2y, that's what I was wanting to get that negative 6y from. And all the way through. And then 3 times 5 is 15. All right. So that allows me to have my opposites I was looking for. 2 plus 9 gives me 11x. Hey, this looks pretty familiar because that gives me 22. And we already know from literally right before that gives us x equals 2. All right, so let's plug it into one of our equations. I'm going to pick 2x plus 6y equals 7. And I'm going to plug in an x of 2. Everything else stays exactly the same. So 2 times 2 gives me 4. Okay, so now we have to undo addition and subtraction first. So I'm going to minus 4 on both sides. I'm going to have to come up here. So those cancel out and leave me with 6y on the left. And then 7 minus 4 becomes 3 on the right. And so, if we divide by 6, we're not getting a whole number here, but it shouldn't be too scary. I know you're probably thinking 2, because 3 times 2 is 6. But it is going to be in the denominator because that's where our bigger number is in the fraction. And so it's going to be 1 over 2 as our answer for y. So we're going to get 2 comma 1/2. Awesome. All right, so at this point in the video, what I would like for you to do is pause it and try number 1. All right, so hopefully you've tried number 1 at this point and you got something along these lines. You multiplied by a -3 on the top. Since 3 and 4 can't really look like each other without changing both, but I can get a plain old x to look like the opposite of 3x if I simply multiply by -3. And then you distributed that -3 to change that top equation, and now you have combined those to solve for your first variable. And you've gotten that y equals +2. Then you went and plugged that value back into either of these equations. You could have picked the second one, but I picked the first one to plug it into, and make sure you plugged it in for y. Okay, we've been solving for x a lot first, and in this case we actually found y first. You plugged it in for y and hopefully got an x of -2, which means your final answer is -2, 2 for number 1. All right, so at this point, pause the video and try number 2. Okay, so hopefully on number 2, we took a look at all these coefficients and we said 2 can't go to 3, 3 can't go to 2, so I'm changing the y's. They're already opposite signs. I need this to become a 6y somehow, and we chose to multiply by a 3. Hopefully we distributed that 3 correctly to each of these pieces and got a 6x plus 6y. Oh, that's right. She's not. See, even I make mistakes. That should be a 15, not a 5. Whoop. That's how easy it can be to make a boo-boo. All right, and then that allowed you to cancel out your y's and get 9x equals 27, and so you got x equals 3. Okay. Then you went and plugged it back into one of your 2 original equations. I chose the top one, plugged it in for x, and I got a fraction again, which is totally fine. And in this case, we would write our answer 3, -1/2. Awesome. All right, so we're going to go ahead and try problems 3 and 4. And something weird should happen with these. So you try it first and see what happens. All right, so let's say, for instance, on the first one, I see here I have a -x and a +3x, and a 2y and a -6y. And I think, wow, if only this were a -3x, it would cancel out with a +3x. So I decide to multiply the top by 3. And that gives me that -3x I wanted, a 6y, and a 15. And the bottom I didn't change, and it stayed 3x minus 6y equals 11. And I start combining these. And just like I had hoped, my x's cancel out. But then I come over here and I look at my y's and I'm going, wait, what's going to happen there? Well, those actually cancel out too. And I'm left with nothing. And on the right, I'm left with 26. And you know where we're going with this. That is not true. So whenever all your variables cancel out, and you're left with something false, you do have to actually say, is this side also equal to 0 or not? Then you're going to have a no solution via elimination. Okay? So in reality, this means I could have looked at the y's and tried to get opposites, or the x's. Both were possible. And when I did that, it'll cause both of these to cancel out. So something similar is going to happen on number 4. Let's say I'm looking at the y's this time, and I say, hey, 2y would cancel out if this were a -2y. So I decide to multiply the top by -2. And that gives me -4x minus 2y equals -8. The bottom would remain unchanged. And I would combine. And I would say, yep, y's canceled out like I thought they would. But then my x's mysteriously cancel out as well. So I'm left with 0 on the left, but you'll notice this time my numbers are actually opposites on the right as well. And so they also cancel out and leave me with 0. So that, as you remember, is a true statement, and it means we have infinitely many solutions. So those are how the special cases will pop up with your elimination method. They are out there, and you should be prepared to deal with them. All right, so for the last part of your notes today, we're going to do this example right here. And this example is kind of the idea of the most difficult kind we can do with elimination, because there's just not a good way to do it, right? We're not going to be able to just multiply something by this bottom x to get a -6. I can't multiply 4 by a whole number and get -6. I also can't multiply 2 by any whole number and get a 3 somehow. So basically, nothing is looking easy. When this happens, it is really up to you. You're either going to decide, hey, I want to get rid of x's, or hey, I want to get rid of y's. Usually, if I already have a plus and minus for one of them, I go with that variable so that I don't have to distribute a negative, because that's the worst. So let's say I want to get rid of my y's. Well, we're going to do this trick here where we say, for instance, you don't need to write this down. I'm just thinking out loud. Right, what's 3 times 2? 6. Well, what's 2 times 3? It's also 6. Multiplication's commutative. It doesn't matter what order we do it in. So if I want these to multiply to the same thing, I'm going to do this trick where I flip-flop them. What? That's right. What are you talking about? I'm saying I bring whoever's the bottom one to the top to multiply, and I bring whoever's on the top to the bottom to multiply. And this is like a guarantee way to get the same number on the top and bottom, because 2 times 3 is 6, and 3 times 2 is 6. The only other thing I've got to make sure I have is 1 is negative and 1 is positive. Alright, so let's get ready to multiply here. We're going to have to multiply twice. And this is where you have to be extra careful, because if you make a mistake at the beginning, it's going to throw you off the whole way through all your hard work. So 2 times 6, that's an arrow, sorry. 2 times 6 is going to give me 12x. 2 times minus 3y will give me minus 6y. 2 times 42, it's going to be 84. Then I'm going to come to the bottom. 3 times 4x is 12x. 3 times 2y is plus 6y. And don't forget the last one. 3 times minus 4 is minus 12. Alright, so I chose the flip-flop of my y's so that my y's would cancel out. And luckily they do. But please be careful and know that this does not cancel out. I know you're thinking, hey, this is like what we did up here where everything can... No, these are not opposites. They are the same. So that means you're actually doubling it. You have two 12x's. So in fact, this actually becomes 24x. And then we'll simplify this. You can think of it as adding a negative, or basically you're subtracting 12 from 84. And so we're going to get 72. And then we're going to divide that by 24, and I think we magically get 3. Pretty sure. You can check me on that later. Awesome. So now we just have to do that fun part of plugging it in and finding the y. Now again, even more so, I would suggest going back to original setups, right? I could plug it into this, but look how big these numbers are. That's gross. Let's plug it into the second equation just to be crazy. So I'm going to plug it into the 4x plus 2y equals negative 4. And I'm plugging in a 3 for x. So where I see x, it's now becoming a 3. It has the 4 out front being multiplied. Then plus 2y equals negative 4. So that's going to give me 12 plus 2y equals negative 4. And then we have to undo addition first by subtracting 12 on both sides. And that gives me, this gets more negative to negative 16. And then finally divide by 2. So I'm getting a negative 8 for y. Awesome. So 3 comma negative 8 is our final answer. Alright, so on these last two U tries, I'm going to go through them with you quickly because I just want to talk about how to figure out what to multiply by. We're not going to do the whole problem. Just that beginning step is the hard part. So for instance, oh gosh, y'all, this has a decimal. That's real gross. So I'm afraid of this, so I'm going to focus on the y's. So in this case, I'm going to flip-flop my y's. So I'm going to say 4 on the bottom and 6 on the top. And then in this case, I do need to somehow have a negative somewhere, so it's up to you where you put that negative. It doesn't matter. I'm going to put it with the 4. Okay, and this is the only part of this problem we're really going to look at. It's just this figuring out what to multiply by and showing that it gives us opposites. Okay, so 6 times 3x gives me 18x. 6 times 4y is 24y. And 6 times 8 is 48. Then on the bottom, you can trust me here, 2 4.5s is 9. So 4 4.5s is 18, and it becomes negative. Oh boy. Then I get negative 24y. And then I get negative 48. Oh, this is a special case. We might as well go ahead and do it. I know, I just said we wouldn't. But look, cancel, 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 cancel. 0 equals 0. Infinitely many solutions. See, that one was just quick. We might as well do it. Awesome. All right, so let's do the last one. Here, because I already have a plus and minus for my y's, I'm going to go for that. So I'm going to say, let's put 3 on the top to multiply by, and 2 on the bottom to multiply by, and then we'll just multiply it. So 3 times 3 is 9x, 3 times 2 is 6y. Oh yikes, y'all, I don't know what 3 times 29 is. We'll come back to that. 2 times 2 is 4x. 2 times minus 3y is minus 6y. And 2 times minus 11 is negative 22. Okay, and after some thinking, I think this is 87. Ooh, I'm not super sure about that. And then we would go from here and actually solve. The point being that our y's cancel out the way we want them to. Alright, so this concludes your video on doing elimination with multiplication.